All right, how's it going, everyone? I know security talks are typically boring as shit, so I'm going to do my best to not bore you guys for the next hour. And we are going to be here for almost the entire hour. I apologize, all right? But it won't suck. Now, real quick show of hands. How many of you in here know what JSON Web Tokens are, maybe even use them, probably like them? Okay, awesome. I have a feeling you guys are going to be really upset today. So I apologize. Now, if you get really upset during this talk, feel free to just tweet hate at me. So this is my personal Twitter account. I have really thick skin. I honestly don't mind. This is my company account. So you could talk shit about me there, although I prefer you don't. You know, you could just say nice things too. It's not that hard. But yeah, basically today I'm going to be talking about something that I really love to talk about, which is that JSON Web Tokens suck, and they're also sort of stupid. So hopefully we have a good time. Now, a little bit about me. My name is Randall Degges. I run developer advocacy at this company called Okta. We're a security company, and what we sort of do is we're an API service. We store user accounts for your web apps, mobile apps, API services, and we do authentication, authorization, social login, password reset, sort of all the typical bullshit you do when you're making user stuff work in your applications. I also do a lot of Python, Node, and Go development. I've been working on open source software for a very long time. I maintain several different security libraries in these different languages, and I have a deep focus in web security. Now, really quick intro for those of you that aren't aware, but I want to cover this just so our bases are square, right? Let's talk about what JSON Web Tokens actually are. And this is pretty much it. It's just some JSON data that's cryptographically signed. And don't worry, we'll talk about cryptographic signatures in a second here. But the important thing you want to know about JSON Web Tokens is that they're not fancy, okay? No one ever looked at the JSON Web Token and said, oh, this is such a cool fancy thing. No, they're pretty basic. It's just JSON data that's cryptographically signed. That's it, all right? The other thing you should know is that like 99.99999 repeating percentage of the time, JSON Web Tokens are not encrypted. And what that means is that if you have a JSON Web Token, regardless of if you have like any special credentials or privileges, you can see all the JSON data stored inside of this token. A lot of people don't realize that. Okay, so JSON Web Tokens are not some like magic bullet to like hide information or anything. That's not what they're designed for. So again, JSON Web Token equals JSON data plus cryptographic signature. Now, that brings us to the next question. What the hell is a cryptographic signature? And the best way I like to explain this is, let's say I write you a letter. I type it up, I print it, and I sign my name at the bottom. And I mail it to you, right? When you get the letter, what you do is you open it, you read all the words, and then at the bottom you look and you see, oh, well, this is Randall's signature. It says his name, it has his handwriting, and I know Randall, I trust him, and so I trust his signature, and therefore I trust that all the words that were typed up are things that Randall wrote to me, right? That's how it works. And that's really what a cryptographic signature is. It's the same exact concept as you signing a letter, just in math. Now, what do JWTs actually do? Also, you can pronounce JWT as JWT, by the way. What do these things actually do? They basically prove that some JSON data can be trusted. That's really it. Now, let's say I go to the airport and I talk to the TSA agent and he asks for my identification. When I hand him my driver's license, what he's going to do is he's going to look at the height, the age, the weight, all these different factors. That's like the JSON data on my license. Then he's going to look at the California driver's license, because I live in California, and he's going to say, you know, I see the stamp of California approval, and the TSA agent, he knows what California is, he trusts it, he knows what the license looks like, that's like the signature, and so therefore he trusts all the JSON data on my passport and lets me through. Making sense so far? I see a lot of head nods, cool. You guys are now experts on JSON Web Tokens, by the way, because that's all there is. Now, let's talk about how people actually use these things, okay? There's several different ways to use them. The most popular way people use them is as identity proof. So when a user's logging into a website, it's basically how we trust and find out who this user is. That's what most of you are likely using them for. I'm guessing that's also why you came to this talk. Now, there's really two ways that people use them as identity proof. And the first way is by far the most common, okay? Like 99% of you, if you're using them, are doing it this way. And that is basically this flow. So let's say a user logs into a website. They send their email and password to the website to say, hey, let me log in. The website's going to check your credentials, validate them, and then generate a JSON Web Token for you. Now, we'll get into the details later. Just let's keep it high level for now. The website's then going to send that JSON Web Token back in a response that your browser receives, where you have written some JavaScript code to take that JSON Web Token and store it inside of HTML local storage, okay? And then from that point on, every time you need to make a request to a new page on the site, you'll have some JavaScript code in your browser that pulls that token out of local storage so you have it again and sends it back to the website so that it can remember who you are by looking at all the JSON data inside of the token. Everyone following? Does that make sense? If it doesn't make sense, raise your hand and I'll just do a quick recap. Now, the second and much less common way people use these things is the exact same way as before, except the data is stored in a cookie instead of in local storage. Now, this is much less common, all right? And I won't bore you by repeating the exact same words. Now, let's get into the fun stuff, okay? What happens when you Google JSON Web Tokens? Does anyone know? Just shout it out. Okay, well, basically you get a bunch of people on the hype train saying, fuck, JSON Web Tokens are amazing. They're like the best security thing that's ever happened. There's a million blog posts, tutorials, YouTube videos, coding boot camps, like classes online, things you can take which show you how to use them. And that sort of pisses me off because every one of those people is wrong, okay? They're all wrong. I'm sorry. But everyone telling you to use them is generally just wrong about it, and I feel bad. And you know, the selfish reason that I actually have for being here today, I'm going to be totally transparent, is that I feel like I'm taking crazy pills because I don't like these things and everyone else does. And it's starting to get on my nerves. And so I need some validation from someone else that like they are actually bad too. So I'm just going to rant for like the next hour basically, and hopefully you guys will like change your mind and maybe agree with me. That would make my confidence go way up. So that's why I'm here today. Now, the technical reason that I think this is sort of a shame that they're so popular isn't really because they suck so much as they're just not as good as session cookies, which is what we're going to talk about today in a lot of detail. But like session cookies are amazing. This is what the web has been built on since the 1990s. It's a super solid piece of technology. So we're going to get into this. Now, I know this is going to be boring, but unfortunately, yes, this is a security talk. I have to define at least some basic terms so we can be on the same page. But we'll try to get through it really quick. Now, the first term you need to know, and don't worry, all your questions will be answered through the course of this. So if you're a little bit lost, don't worry. The first term we need to know is what a stateless JWT is. Now, a stateless JWT is a JSON Web Token that contains all of a user's information. So let's say you have a user in your database and they've got like 20 different fields, like a favorite color, an email, a first name, a last name, etc. A stateless JWT would basically contain all this information in the JSON data that's in the token. And that's pretty much it. Now, how do these things work in the real world? Well, let's say a user's logged into a website and makes a request to see a page. What happens? Well, the first thing that's going to happen is the website's going to look at that JSON Web Token and it's going to validate it. It's going to check the signature. Like I mentioned before, the signature lets you trust that this data is basically accurate. So it's going to validate this token. Then the website's going to look inside the token's JSON data, and it's going to extract all that information, your email, your first name, your favorite color, your birthday, whatever. Then it's going to use that information to render a page and show it to the user. Make sense? Cool. Yeah, nothing special here. This is basic session management. Next up, let's talk about what a stateful JWT is. All right? Now, a stateful JWT is a JSON Web Token that just contains a single piece of information, a session ID. And that's it. Now, what this means is all the user's information is stored in a database in your network, not inside of this token. And so let's see how this flow looks. Well, let's say the user has a stateful JWT and is logged into a site and wants to view a page. They send a request to check out the page. It's going to validate the token again. Same thing always, right? The website's then going to extract the session ID from this JSON data. It's then going to talk to a database, a cache, whatever you have internally to say, hey, here's the session ID. Who's the user that owns it? What's all their information? The database is going to do a query, look it up, return the information to your website, where you will then render a page and show it to the user. Sounding good? Cool. Next up, let's talk about what a session cookie is, all right? This is basically a cryptographically signed session identifier. So you know that session ID you just saw in that example, 1, 2, 3, 4, 5? You know, that really random, awesome, strong number. Well, a session cookie would be a cookie that just contains that number, and that number is cryptographically signed. So there's no JSON data whatsoever. It's just a number, and that's it. Making sense? Great. Now, let's see how this flow looks. The user's logged in. They send their session cookie up to the server. The website's going to check the signature again, just like it did with the JSON Web Token, because cryptographic signatures work, you know, on JSON Web Tokens, outside of JSON Web Tokens. It's a general practice thing. And then it's going to get the session number, or the session ID, then talk to the database, etc. Now, you might be wondering, what's the difference between a session cookie and a stateful JWT? Okay, that's pretty fair. Those flows look almost identical. And here's the thing. They're both cryptographically signed, like I mentioned, which is awesome. And they both contain a session identifier. But one is using the JSON format, and one is just the plain old session ID number on its own. That's it. Nothing special there. Super, super basic. Now, let's talk about cookies. Now, I'm sure you're all very familiar with cookies. This is going to be a quick recap. But cookies are basically the original NoSQL database of the web. Okay? They're a key value store that your browser lets you store stuff in, and that's pretty much it. The only thing that's different from a cookie and MongoDB is the size limit. Okay? A cookie can store 4 kilobytes of data max. MongoDB can store at least 100 gigs max or something, probably. No laughs. What? Guess everyone here likes MongoDB somehow. Anyways, let's talk about creating cookies. So when a user logs into a website, how does your web server actually tell the browser to remember something, to create a cookie? Let's take a look. When the user logs in, the website, when it sends a response back to the user, will send back this header called the set-cookie header. All right? And inside of it, it's a key value store. So it says, for instance, session equals, session is the cookie name. And then the value on the right is just the cryptographically signed 12345 session identifier. This is like a legit way to set a cookie, okay? Now, once the browser sees this, it's going to create the cookie. And if you want to create multiple cookies in the same HTTP header, you can easily do so by just tacking a semicolon on the end and defining some more A equals B style things. Really, really simple. Now, one quick note. Whenever you're defining cookies, you always need to include 2 separate cookie flags, all right? You just tack these on with semicolons at the end. The first one is called HTTP only. And what this does is it tells your web browser, hey, browser, never let any fucking JavaScript code see this cookie. And that's the most important part of this talk, because here's the thing. The most dangerous thing in the entire world, like by far, is actually just JavaScript, okay? So guns are pretty dangerous, for sure, because you can hurt yourself or other people. JavaScript hurts like everybody, so it's pretty bad. Now, next up is this same site flag, all right? Now, I'm not going to get into the details of this because I will run out of time. I time myself. But basically, this helps prevent cross-origin request forgery attacks, and we'll get into it a little bit later. But you need both of these to do a good job. So we talked about creating cookies, right? Now, how does our web server actually read these cookies and find out who the hell somebody is when they have a session? And the way it works is when the user makes a browser request to a website, that browser is going to automatically send back those cookies in the cookie header. So the same data you set previously will just be echoed back with the header named cookie. Make sense? Cool. Your website will then parse out that cookie header, extract the session ID information, and do whatever the heck it wants with it. All right, last definition, I promise. Won't go on forever. But who here knows what HTML local storage is? Please raise your hand. Hi, hands. Okay, everyone, great. So local storage, JavaScript API, only works in the web browser that lets you store data. Now, it only lets you store string data. You can store basically up to like 5 megs generally across like different browsers and stuff, so quite a bit larger than cookies. But that's what it's for. And most people consider local storage to be the only real alternative to storing data in the browser outside of a cookie. Now, it's not technically true. You could use IndexedDB. You could use the cache API with web workers. But we're not going to get into that because for all intents and purposes, they're basically the same shit. So now the fun part. Let's talk about the myths about JSON Web Tokens. This is what I've been waiting for, like all day. So the first myth, all right, is that JSON Web Tokens are easier to use than traditional server-side sessions and session cookies. let's get into this for a sec. Now, JWTs basically came around. The first draft was published at the very end of 2012, early 2013. Pretty much nobody used them for a year and a half afterwards. It wasn't until mid-2014 that like they actually got any sort of usage whatsoever, really. If you've ever used JSON Web Tokens before, you will know that integrating with them requires you to understand what a JWT is, use a JWT library in your language, in your web framework, and basically figure out how to piece this stuff together. So it's not super simple, right? Now, session cookies, on the other hand, they've been built into pretty much every single web framework since 1994. And they require zero effort to use. Like, you would never see a talk titled "Why Session Cookies Suck," because they've been around forever. There's nothing that sucks about them, all right? And so I'm going to keep score here, and here's the thing. If we're keeping score, just theoretically, right, JSON Web Tokens have a score of 0, and session cookies have a score of 1. Now look, it's early in the morning, and I appreciate that we had a party last night, but you guys need to like get pumped up, okay? So what we're going to do is I'm going to say JWTs, and you guys say 0. You say 0. 0. I like the enthusiasm, but we're not there yet. So I'm going to say JWTs, and you guys yell 0. And I'll say session cookies, and you guys yell 1. Cool. This is great. The people in the other rooms are going to be so jealous that we're having so much fun. All right, now, the next myth, that JWTs are somehow more flexible than session cookies. Let's dive into this. This is what a JSON Web Token payload actually looks like, okay? Some user information. And a lot of people think, you know, JSON Web Tokens are awesome because, A, they're storing stuff in JSON, which is fucking super cool, right? JSON's amazing. But you can actually do the exact same thing inside of a session cookie. Now, if you remember a second ago, the way cookies are created is just that long HTTP header field, and you say key equals value semicolon. So I can always reproduce the same key value data inside of a session cookie if I want to. It's just super easy, just like this. Now, in the real world, I would never do this because in a session cookie, I'd only store a session ID. I wouldn't actually store like my email, my first name, my last name, stuff like that. But this is just an example, right? So there's not really any difference in flexibility. Now, some of you, as I was talking right now, probably got really upset because you're like, Randall, you're a noob, okay? JSON Web Tokens aren't more flexible because they have JSON data. They're more flexible because they have all these cool things called claims, all right? Now, here's the thing. JSON Web Tokens basically have these extra properties embedded inside of them called claims. They're just JSON data again. There's a bunch of standard ones, 2 of which, one is called IAT, which is short for issued at. One is called EXP, which is short for expires at. And the values of both of these fields are Unix timestamps. And they basically allow you, as a developer, to define when does this token expire? Like, when do these credentials become invalid? And that's pretty cool, right? It lets you basically set an expiration time for this user's login data. And that's actually really flexible. But what people don't realize is that that shit's been available in cookies since 1994. So, like, I don't get what's up with that. Like, there's no difference in flexibility, guys. I'm sorry. And so, again, unfortunately, the scoreboard is now JWTs, session cookies. Cool. Now, it's probably going to catch up a little bit, by the way, so don't be surprised when the numbers start going the other direction. Now, next myth. JWTs are more secure than session cookies. And this is a big one. And the reason it's big is because a lot of people in the security community promote these things on the premise that they are more secure or more scalable or whatever. So let's talk about it. Now, let's take a look at JWTs. They're cryptographically signed. Fantastic. They can also be encrypted using a spec called JWE, JSON Web Encryption, although nobody uses it because it's really complicated and it sort of sucks. Now, the bad side is the spec is complicated. Now, I'm not talking specifically about JSON Web Token. I'm more referring to the family of specifications it's a part of called the Jose family of specifications. This includes like JSON Web Signatures, JSON Web Encryption, etc. Over the last year and a half, multiple vulnerabilities have been found in popular JSON Web Token libraries. Now, and I'll cover this in a second, right? There's also vastly different support across libraries and languages. So what I mean by that? Well, if you look in the Node.js community, there's a few different types of JSON Web Token libraries people use. Same in the Python community. And because the spec is so large and there's so many different algorithms to support and all the different related Jose family of specifications, almost none of these libraries support the exact same options. And that makes it really hard to build services that talk back and forth to each other back and forth to each other over a network, because these things have different types of support. So if you have a Node service talking to a Python service, that can actually be pretty damn hard to get working right. Now, a lot of this, I'm going to be fair to JSON Web Tokens, is actually because they've only been around for a couple years, right? People only started using them halfway through 2014. And so a lot of the open source libraries aren't super mature. A lot of them haven't been cryptographically audited. A lot of them have just not been around long enough to mature to the point where they're super easy to use. But let's compare that with the track record of session cookies, right? Also cryptographically signed, can also be encrypted. Been around since '94. Zero complexity in the spec. I walked you through the cookie spec like 5 seconds ago. You know everything about it, all right? And there's identical library support everywhere, all right? It's impossible to mess this thing up. And so from a security track record alone, the point is going to session cookies. So what's the score? JWTs? 0. Session cookies? 3. Cool. Next up, how many of you have ever been on a website and you see that annoying banner pop up that says, hey, just want to let you know we're using cookies. If it's cool, like click here, right? Like, I don't want to feel bad, but you know, we have to tell you. That's something that came about due to the EU cookie law, which was passed in 2011. It only started getting enforced in the EU in 2012. And basically the European Union decided enough is enough. People are tracking users, doing all sorts of crazy stuff. If you're doing that, you need to show this banner at the bottom of your website. Now, unfortunately, what a lot of developers thought when this law was passed is that basically there's a misconception that like if you're storing information inside of a cookie, like user information, for instance, you need to show this banner. And so what a lot of developers did at the time is they said, well, you know, if I'm using a JSON Web Token and I store it in HTML local storage, I am exempt from this law because this law is talking about, you know, cookie security. And I'm doing stuff in local storage, and that just doesn't count. Right? That's actually a myth, though, because what the law actually says has nothing to do with cookies at all. It really only matters how you're storing people's personal information. So for instance, if you're using Google Analytics, Kissmetrics, Optimizely, any sort of ad network code, optimizing code, A/B testing code, anything that's storing information about the user that's not absolutely essential to log them into your website, then you need to show this banner regardless of if you store their data in a cookie or local storage or any other place. All right? And it's just sort of a fun fact as well, the text in the actual directive, the cookie law directive, actually says information stored in cookies or wherever for authentication purposes is exempt. So this is just a huge misconception that people have. And so again, the myth that JWTs allow you to somehow bypass the cookie consent law are false. So what's the score? JWTs? 0. Session cookies? Cool. All right, next up. How many of you in here know what cross-site request forgery is? Shoot your hands up pretty high. All right, this is going to be a review then. But let's talk about what CSRF actually is real quick. Now, let's say you have an online bank account and you want to go check your accounts. So you log in, you start browsing the website, checking accounts, etc. Let's say that your bank also has a transfer page where you can transfer money. You have a form on that page that has an amount field and a to field that's an email address that sends who you want to send money to. Well, what happens if you also have a friend that's sort of an asshole, all right? Like most of us have one of those friends. And you know, in the case of security people, this happens quite frequently. Your friends will send you HTML links, and you click them, and they're just basically trying to fish your information out of you. Now, in this case, what's happening is this jerk friend has sent an HTML image tag over. I know it's hard to see in the back there, but the source of this image is basically going to bank.com/transfer, amount equals 1,000,000, and to equals jerk@gmail.com. So what happens? Well, if this user's logged into the banking website, and he has his authentication data stored inside of a cookie, then when he clicks this link, that image will load, and it will make a request to the banking website. And depending on how the bank actually wrote their web code, those query strings in the URL can sometimes be interpreted as form input data. And so it might actually submit the form to transfer $1 million to this guy's jerk friend. And that really sucks, right? Because the bank will happily do that. Now, the ending to this story, of course, is that your friend will then take all your money, cash it out for Bitcoin, and then a week later, when it triples, he'll just like move to Russia. Now, well, let's revisit the myth now that JWTs prevent cross-site request forgery somehow. Now, here's the thing. They don't. but I'm going to explain it why instead of just giving up points right off the bat. And the reason why is because it has nothing to do with the JSON Web Token protocol. It has everything to do with where the data is being stored. So for instance, let's say that you store your JSON Web Tokens inside of a cookie, all right? No matter what data you store in a cookie, if it's session data, you will always be vulnerable to cross-site request forgery attacks like the one I just showed you. And CSRF is really just a social phishing attack, basically. You're trying to convince, excuse me, you're trying to convince people to do something that they're not aware of. Now, let's say you store your JSON Web Token in local storage instead. This will actually fix the problem entirely. And the reason why is because local storage is a JavaScript API, right? It only works in JavaScript. And if I were to have my session information inside of local storage, then when my friend tricks me into clicking that link, unless I wrote JavaScript code to pull my token out of local storage and send it to that transfer page, it will not get my authentication data. And so the bank will see me as being logged out because I haven't specifically written code to use my token for this purpose. So local storage actually fixes the cross-site request forgery problem entirely. Although, and this is a big one, it opens you up to a much worse type of attack called XSS, also known as, or otherwise known as, cross-site scripting attacks. Now, CSRF is actually really trivial to fix. So ever since cookies have been a thing, people have known about cross-site request forgery attacks. They're really, really common. And in every single web framework, in every single programming language in the history of humankind, right, there are tools built to handle this stuff automatically for you. In the Python world, in the Ruby world, in the Java world, et cetera, there's like things you can use one line on to just fucking handle this for you, which is pretty cool. Now, cross-site scripting attacks, on the other hand, there's not really a great way to fix these. As a matter of fact, they're one of the most difficult types of things to fix out of everything on the entire web. This is why they have consistently been a top 10 like common vulnerability like forever. Now, show of hands, and I want them high in the air because I'm going to be counting, all right? How many of you have ever embedded third-party JavaScript in your website? Google Analytics, Twitter Bootstrap, jQuery, Vue.js, React.js, anything. Now, I see a lot of hands, but I also see a lot of fucking liars because guess what? Every one of you that didn't raise your hands, you guys are lying. I know you've all done this. Don't lie to me. Everybody's done this. If you follow any tutorial ever, even for testing, you have done this. And the thing about this is third-party JavaScript is bad news for you, right? Really bad news. And the reason why is because let's say you're storing your JSON Web Token inside of HTML local storage, okay? That data can only be accessed via JavaScript, right? So what happens if you're linking to a third-party JavaScript library and the JavaScript code you're linking to gets hacked or compromised so that instead of loading Bootstrap, it decides to load all of your tokens out of local storage and then send them off to a third-party API to collect all of your personal information. That's basically what this is. If an attacker can run JavaScript on your web page, they can compromise you. Now, a lot of people I've talked to say, Randall, that's actually not a big deal because I'm a really smart developer and like I will never run third-party JavaScript on my site. And every time I hear that, I'm like, all right, hold up, because like there's no way. Like the chances of you doing that are like slim to none. Now, if it's a personal project and you are the only person working on it, sure, whatever. You can maybe do that, right? But let's talk about the real world for a second. Even if you can control your website, you can't control a user's Chrome extensions, for instance, which are running JavaScript on your web page. You also can't control things, for instance, if you work at a big company and maybe you have a marketing team managing your public website, right? In a lot of those cases, it would be very difficult to make some rule that the marketing team cannot use any sort of third-party JavaScript. Pretty much all marketing tools are built on top of third-party JavaScript, all of them, okay? So in the real world, this is basically impossible to prevent. And so because of that, you should basically never store anything sensitive in local storage ever, like ever. And this right here is one of the things that pisses me off the most online because every single tutorial you see about using JSON Web Tokens says, here's how to do it. You get them, you store them in local storage, that's the best thing to do. This is OWASP, the Open Web Application Security Project. This is a direct quote from them. And they basically say, hey, that's stupid. Don't store anything sensitive there ever. And I would actually argue that like, you know, of all sensitive things to store, the most sensitive things is your user's JSON Web Tokens or their session IDs. The reason why is because that gives you the keys to the kingdom. If someone has that, they can log in as you, they can make requests as you, they can do whatever the hell they want. And so it's a really, really bad idea. So if you ever get this advice, run away. It's not good advice. So let's go back to the score. JWTs, Session cookies? Cool. Now, a lot of people say JWTs are better if you're building a website where the user needs to be logged in across multiple domains. So that could mean multiple top-level domains. It could mean multiple subdomains. But this is a really common argument people have for using JWTs. They say, well, because my JWTs are typically stored in local storage, using JavaScript, I can get around the problem that cookies have, where cookies are typically bound to a single domain. And so if I'm using JWTs in JavaScript, I can just send an API call out and send my authentication data wherever I want. Now, we talked a second ago about why local storage is an unacceptable solution. And so I think we all know that this is bullshit. But before, instead of me just recapping the same thing we just talked about, what I'm going to do is I'm going to teach you the right way to do cross-origin authentication without using JSON Web Tokens in local storage, okay? Now, pay close attention, because this is pretty cool. Let's say you have a public website on www.example.com, and the user wants to log in, so they click the login button. Well, your public website doesn't do authentication in this scenario, so it redirects you to the login subdomain that does. So now the user sees a login page, and they're on login.example.com. So what happens next? The user submits their login info to the web server. The web server checks the login info, the email, password, or whatever, makes sure it's valid. Then it logs the user in with a cookie, a session cookie, onto the login subdomain. So now the user is logged in on login.example.com. They have a cookie there, so they're good. But we're going to do something else sort of interesting. We're going to generate a JSON Web Token that lasts for 10 seconds, okay? And then this login domain is going to redirect the user to the dashboard subdomain. And it's going to include that JSON Web Token that was just generated in the query string. So what happens is basically the user is going to make a request to dashboard.example.com, token equals your JSON Web Token. And now what happens? Well, the dashboard gets that request, parses the JSON Web Token out of the URL. It validates the signature, like we talked about, cryptographic signatures. And then it creates a cookie for you on the dashboard subdomain. So now we have two cookies, one on login, one on dashboard. The user is logged in securely using a cookie, and we haven't used the JSON Web Token for storing the actual authentication data, okay? And finally, because the user's logged in, they can now see the dashboard page, and bam, we just handled cross-domain authentication. This will work on subdomains, top-level domains, however many you want. And what's interesting about this is we're not using the JSON Web Token for anything authentication related. We're specifically using it as a one-time token that lasts for a very short duration. And we'll talk about this more later. But the idea that JSON Web Tokens should be used to get around issues with cookies and cross-domain stuff is incorrect. And so the scoreboard, we're back to this. So JWTs, session cookies, cool. You guys are getting a little better at this, but I think we need to up our game. Now, next myth is that JWTs are better for mobile sites. Now, the context about all the stuff I'm telling you today is really scoped around web authentication, because I literally don't have the time to dive into the OAuth protocol and the OpenID Connect protocol and rip all over those for a while. But here's the thing. If you're building a mobile app, the web browser in your mobile app works the same as the web browser on your tablet, which works the same as the web browser on your desktop. So no, it works the same anywhere. Session cookies work the same. JSON Web Tokens still suck. Now, easiest point ever. So let's see if we can muster some more enthusiasm. So JWTs? 0. Session cookies? 7. Cool. All right, next up. People say that JWTs are more efficient than session cookies. This is a really common argument. And so I want to give you guys some fucking science to back this up. Now, here's what I did. I wrote a script, and I'm comparing a JSON Web Token, a stateful JWT that just contains a session ID, to a session cookie, basically, a cryptographically signed session identifier. So here's what I did. I'm going to walk you through it. I wrote a node script using the JSON Web Token library. It's like the most popular one in the JavaScript community. I picked that just because I figured most of you use JavaScript. And what I did is I created a JSON Web Token that looks just like this. It has a session ID inside of it. It's a 40-character long, randomly generated string. Then I created a second test down here, which is that same exact string that's been cryptographically signed. I'm not going to talk about the specific details here. And both of these are going to use the exact same cryptographic signing algorithms, okay? They also both have a signing key, which is the exact same key. They're both 40 characters long, randomly generated strings. So this is a real-world scenario. This is something that would actually happen. Now, what happens if you just compare the size of these two things? Well, what you'll see is that the JSON Web Token is 179 bytes, and the signed session identifier is 64 bytes. Now, these contain the same information, except the JSON Web Token is roughly 3 times larger. Now, part of this is because JSON Web Tokens, for the most part, tend to include those extra claim things inside of the payload by default. And part of it's due to the overhead of JSON serialization. Like, you need squiggly braces, you need quotation marks, you need some other stuff, right? But it still comes down to the bottom line, which is it's a little bit larger. Now, we're talking about a really small number of bytes here, right? Like a kilobyte is like 1,024 bytes. So this is very small. And you might be thinking, well, Randall, you're like dramatically overstating the importance of efficiency in these things, because if you can't send a kilobyte over the internet, then like your internet connection really sucks. But here's the thing. This isn't actually a real example. Now, in the real world, when people use JSON Web Tokens for session management, they use stateless tokens, right? They actually include all the user information inside of it. So what I did is I did another test. And in my second test, what I did is I took 4 fields. I basically created a JSON Web Token with 4 fields: my first name, my last name, my email, my favorite color. All right? And I created that. And what I learned is that the JSON Web Token, the resulting token, was 10 times larger than the session ID. And then what I did is I actually built a lot of apps for work. So I work on a lot of projects. I just looked in a typical database for one of the applications I write, and I pulled out a single user record. This record had maybe 15 fields in it, which is very low for most applications. Most applications have user information with way more than 15 fields. And when I serialize this data into a token, I see the token becomes 25, 30, 40, 50 times larger. Now, in real-world applications, it's likely going to be much larger, way more than 50 times larger. And so what that means is, I'm going to break it down. If you are doing JSON Web Tokens statelessly, there's almost no chance in hell that that token is going to be less than 4 kilobytes large, all right? And if you remember, cookies can store a maximum of 4 kilobytes in the browser. And what does that mean? Well, if you can't store it in a cookie, you basically have to store it in local storage. And what do we know about local storage? It fucking sucks. So basically, there's really no secure way to store JSON Web Tokens because of their size, all right? And so they're also just not efficient, right? They're much bigger and sort of useless. Now, does that make sense to everybody? Great. So let's go back to the scoreboard. JWTs? Session cookies? Cool. Next up, a lot of people talk about the fact that JWTs are actually easier to revoke than session cookies. And this is a pretty interesting argument. Let's see how it pans out. Let's say a user logs into a website and gets back a JSON Web Token. And they're just a typical user, so they just store it in local storage. So a little while later, that token gets compromised, probably because they're using local storage, right? And then eventually, you as the website owner detect that this person's account has been compromised because maybe there's a lot of requests from Russia or something, and you're like, shut it down, right? And so what do you need to do to quickly remove this user's access? Well, what some people do is they say, hey, you know what? I'm going to change the signing key. Now, if you remember cryptographic signatures from earlier, let's say I write you a letter and I sign my name Randall Degges. Well, what happens if I illegally change my name to Tom after I send you 100 letters, okay? Those papers are no longer mine anymore. The signature is invalid. And so you will not be able to recognize who it's from. The same thing is basically happening here. If I go into my website and I change the signing key to something new, I basically just changed my name, and I can't trust shit anymore. And so what happens? Well, this user gets logged out, as well as every other user logged into the website. And that's a pretty shitty experience, right? You've just logged everybody out all at once. So that sucks. Now, those of you that are more advanced and have done this stuff in production will probably say, well, Randall, you're being a total noob right now. You're unfairly representing JSON Web Tokens. Because if I want to invalidate a token and just log one person out, then I can use a revocation list, all right? This is a really common pattern where basically you say, I'm just going to keep track of these things and just log one person out. So let's take a look at how this works. If you're using a revocation list, the user's logged in, then every time a user makes a request to your website, what you do is you take their token and you check it against some sort of database. It could be a cache, could be Postgres, Mongo, whatever. And you say, hey, database, has this token been revoked? And to do this, you're basically going to need to keep track of all the tokens you create and whether they're valid or not. So then you ask your database, the database is like, yeah, this token has been revoked, and then your website can shut this person off. But here's the thing. Why? Because if you're doing this, you've lost the one benefit of JSON Web Tokens that people love the most, which is that they're stateless and that you don't need to talk to a database to use them. And so this is just a huge misnomer that it's somehow easier to revoke things with a token. And so again, going back to the scoreboard, we got JWTs, session cookies. Good. Now the scoreboard might get evened out really soon, so don't get too excited. Next up, JWTs are easier to scale, right? Maybe this is the one where they win. Now, let's take a look. So JSON Web Tokens, right? On the positive, they can be validated cryptographically without any sort of external database access. That's pretty cool. On the downside, though, this only applies to stateless JWTs, right? That have all the user info embedded inside of them, not stateful JWTs. And on the downside as well, they require more bandwidth on every request, like we've explained. Now let's look at session cookies. Session cookies can use different types of server-side infrastructure to speed them up. They require less bandwidth for users to use. Those are both good things. But on the downside, they do require a centralized cache of some sort to make them work. And that sucks. It's not very scalable traditionally, right? But real quick, before I get into the details, I'm going to mention one thing, which is just my opinion, okay? So feel free to have a different one. Now, let's say that a user is talking to your website. Most users, when they talk to your website, they're not on Amazon Web Services. They're actually on a laptop at their home on Wi-Fi through Comcast. They're in a Starbucks. They're on a mobile phone. They're on a shitty tablet, whatever. They're on consumer-grade internet connections, which suck, all right? Now, the whole idea of storing a JSON Web Token that has everyone's info in it on one of these devices, you're basically saying, like, hey, user, I want you to remember all of these things and send it back to me when you make a request to my site on every request. And that puts a lot of data burden on the user to send that back and forth on every page request. And again, users' connections are typically slow. And so when I compare these two things, I actually like to think of it like this. If you're using a server-side session and you're grabbing user information out of a cache or out of a database, you are on a much more high-performance network than the user will ever be. If you're running on any reasonable type of infrastructure, I guarantee you're on a much better network. And so the size penalty, the bandwidth penalty for you doing these operations is much less than the user. And so I always err on the side of server-side management in general, just because I know that users' connections are slower than mine. Now, we've already talked about all these other reasons why you can't really use JSON Web Tokens practically, and so I think we all sort of already know where this is going, that they're not more scalable, right? But instead of me just giving a point, I want to explain the proper way to scale out sessions on the back end. Now, let's talk about this real quick. A lot of people think scaling sessions is really hard, they're not scalable, which is total bullshit, of course. Let's say you have a website, and you have a few hundred, a few thousand users, maybe even like 100,000 users. How do you do session management? Well, when the user's asked to view a page, you grab their session data, you talk to your database, Postgres, MySQL, whatever, and it grabs their info and sends it back, and then you fulfill the request. Now this works because guess what? 100,000 users isn't actually all that many. And so the amount of database lookups you'll need to do is relatively low. People aren't logging in all the time. We can cache a lot of this stuff in memcache on the server side. There's a lot of options here. And this will work on a single web server and be really basic. Now, what happens if you're working on a larger site? So you have a few 100,000 users, a few million users, okay? How do you scale it up then? Things get a little more complicated. And basically, when you have users more than a little bit making requests, you basically do the same thing. You just scale it horizontally. So you say, hey, guess what? Instead of just asking one cache or one database for this user info, I'm going to spread it out horizontally across several different memcache servers, several different Redis servers, several Postgres servers, whatever you want, right? But it's actually not very difficult to do. In languages like Python, Ruby, Java, you can make this change with a single line of code. You can modify config and immediately start talking to many different caching servers or database servers to handle this for you. These are all really solved problems. Now what happens if you get real big, right? If you are like Facebook big and you got like millions and millions of requests or hundreds of millions and you need to do the same thing. Well, basically, the answer, without going into an incredible lot of depth, is you want to move things to the edges. So you're going to run copies of your infrastructure at different geographic locations, and then inside of each of those locations, you're going to have the same exact horizontally scaled cluster of caches. Exactly the same shit. And that's pretty much it. So it doesn't actually have to be a really difficult thing. Yeah, it might be a little expensive, but guess what? If you're running a website with hundreds of millions of users, things are going to be a little expensive. Now, let's go back to the scoreboard. JWTs? Session cookies? Cool. All right, next up. JWTs are secure by design. Now this one is something I think is actually really interesting just to think about conceptually, okay? Let's say a user logs into a website and gets back a JSON Web Token. And then let's say you decide, you know what, Randall was an admin when he logged in, but he's been deleting other users' accounts, so we're going to revoke his access. So they delete my admin privileges. Well, if using JSON Web Tokens statelessly, what happens? Well, if I continue making a request to the website to say I want to delete stuff, the website's just going to say, okay, sure, right? And the reason why is because there's no central store of whether or not this thing is good or not, right? It's just trusting the signature, okay? And that is actually really bad news for security. Now, something you may or may not have heard before, but in every piece of software ever, you have two choices. You can be really fast or you can be really secure, but never both. Never both. It's a direct trade-off for everything in the security world. There's always that trade-off no matter what you're doing in what circumstance. Now, you can speed things up a lot to get past a lot of this, but here's the thing I want you to think about. The JSON Web Token protocol is not designed to store things securely. That's not what it's for. I'll explain the purpose in a minute, but that's not what it's for. And so anytime you're caching sensitive information that has real implications to being non-real time, let's say, you are at risk of security incidents. It's just the way that it is. If you're trusting something that might not be accurate, that is a security issue. And so just think about that. Whenever you're building software, you need to really strongly consider, like, should I be using something like this or not? And so, again, JSON Web Tokens are not secure by design, and they should not be used for security purposes. So, with that said, let's go back to the scoreboard. JWTs? Session tokens? Now, you probably thought I was going to stop at 10, right? And we're already at 11, and you're probably like, well, he's been going for 46 minutes, and this is getting sort of ridiculous. So I will stop here. We could go on, but this is where we're going to stop, because I need to squeeze in some other stuff. But I could keep going on. That's the important point to remember. Now, I just sort of like ruined JSON Web Tokens for a lot of you, I'm sure. But you're probably thinking, well, okay, I sort of agree with some of your points. I'm sure you're exaggerating like everything. But what are you going to expect from a conference speaker, right? They're just going to exaggerate. So how should I actually use these damn things? Because like they're so popular, people online can't all be wrong. Like how do you use them? So here's two popular use cases to use JSON Web Tokens. The first is, let's say you're running a website where you sell like videos or web themes or whatever, website templates. And you let users download them. So if a user pays for a file and wants to download it, they send a request to your site and click the download button. And they're like, I want to download this. So what does your website do? It creates a JSON Web Token that lasts for 1 minute. And then it redirects you to the download server. So for instance, it might redirect you to download.website.com token equals, blah, blah, blah. Then what happens is that once that download server retrieves that request, it's going to parse that token out of the query string. It's going to validate it. And it's going to say, you know what? This is valid. So sure, you can download this file. And then it's going to let the user download the file. And this is really nice because now your file server's implementation logic is like one line of code. It's like, is the signature valid? Yes, then let them download it. And that's pretty nice. It gets you really far. And this is a great use for a JSON Web Token because the token's being used a single time and it expires in a very short amount of time. All right? Again, it's not being used for a security purpose here. It's being used as a one-time token that expires really fast. Now, let's talk about JSON Web Token use cases, a second one. And this is password reset. Let's say a user goes to the website and says, I want to reset my password. Well, what you can do is you can generate a JSON Web Token that expires in, let's say, 30 minutes and email it to the user inside of a link that goes back to your website. And so what happens if the user clicks that link from their email client and goes back to the website, then what do? Well, you validate the JSON Web Token. You say, oh, the signature is good. It's not expired, right? It hasn't been 30 minutes yet. And then you say, sure, I'll let you reset your password. And then you let them reset their password, and everyone's happy. This is another sufficiently OK use case to use a JSON Web Token. And again, the two properties that make it OK to use it is being used a single time and has a short expiration. Those are critical. So you might also be wondering, well, everything makes sense, but why are JWTs so popular? Like, why would so many people online be talking about them, and why would all this stuff be around them? Like, it just doesn't make sense. If they suck this bad, then what's going on? And here's the thing. It's sort of my fault, but sort of a lot of our faults in the security world. And I'm going to call some people out specifically, including myself, right? So companies like me, I used to work at this company called Stormpath. I work at a company called Okta now. There's Auth0. There's a lot of different companies which are basically authentication as a service providers, okay? And what all of us do is we basically handle authentication concerns for our users. We build developer libraries that let them reset passwords and log in and handle OAuth and stuff in a really simple way. And here's the thing. The security community and industry is really boring, all right? Things almost never change. Like, it's a glacially slow process. I mean, bcrypt was invented in 1996, I believe, or 1998. And that's still the major in-use password hashing algorithm today, all right? Things basically rarely change, and they move at a very slow pace. And so a side effect of that is that us in the security community, when new stuff comes out, we get sort of excited about it, and we like play around with it, we tinker with it, and we try to find really cool use cases. And unfortunately, some of the first use cases we played around with were basically using these things for authentication. And it turns out that that's not such a good idea for all the reasons I just described. But here's the thing. JSON Web Tokens got popular because we talked about it, and we said, hey, this is a cool new security protocol. Look at how easy it makes the session stuff. It makes it really stateless, et cetera, without thinking about the implications. More and more people started to use it. It got popular. And what ended up happening is that because it's popular, when people search for it, they land on our blog posts, which talk about it. And we're selling a service. And so it's great marketing for us to promote these things because we make money off of it, right? Like, if we are sharing this stuff with our users and people are coming to read about it, they not only learn about JSON Web Tokens and why they're hard to use, but they also learn how our service can help do this better. And so, unfortunately, JSON Web Tokens have sort of transformed from a technology and security thing into more of a marketing thing. So today, a lot of this is actually fueled by marketing and has nothing whatsoever to do with the underlying technology. That's sort of at a detriment to most of us in this room, unfortunately. And this includes me, by the way. Now, you don't necessarily need to trust me on this. You can validate it for yourself. So what you do is open up an incognito tab, search JSON Web Token, and look through the Google listings. Now, when I did this, here's what I saw. 1, 2, 3, 4, 5, 6, 7. The top 7 out of 10 articles are actually marketing material, right? Now, they are educational, but their goal is to market to you and teach you and get you to sign up for a service, okay? And so my call to action for all of you in this room today is that I really want you to stop using these things, all right? Just stop. Now, you'll make the web safer, you'll be a lot happier, your job will be easier. And I just want to say a huge thank you to coming to this talk today. I really enjoyed being here. This is my first time at CodeMash. I'm having a great time. This is already one of my favorite conferences. And if you want to hit me up, you can hit me up here or there. We have a few minutes left. And finally, before I take questions, I want to point out one more thing, which I think is actually hilarious. But if you dislike JSON Web Tokens now, like I do, I actually created a t-shirt that you can wear to say that you don't like them, and then you can tell other people why not. So.